Chapter 5, Number 3. In a grocery store, you push a 15.4 kilogram shopping cart horizontally with a force of 13.4 newtons. If the cart starts from rest, how far does it move in 2.50 seconds? We will assume that this is the total force on it, or that there's no resistance in the axles or something like that, because otherwise we don't know what the friction is and we can't really do the problem. So we will assume that our shopping cart, and we push with it, and that's all that matters. So therefore, if we draw a free body diagram really quickly, I'm going to ignore the vertical forces because they just cancel out. So we have the pushing force, and that tells us that the net force on the cart in the x direction is just the pushing force, which is 13.4 newtons. And then I'm going to say, oh, well, then the cart moves over by some amount because it picked up some acceleration. And now it has some velocity at the end. It started at 0 seconds and 0 meters, and we are at 2.5 seconds, and we'd like to know where do we end up. So we use our kinematic equation, x equals x0 plus v0 xt plus 1/2 ax t squared from chapter 2, and we connect it by saying, oh, by second law, not only is the sum of the forces just Fp, but the sum of forces is always ma. Sorry, that came out pretty badly. So let's fix this. The sum of the forces is m times the acceleration in that direction, meaning the acceleration is the pushing force over the mass. And so we end up here, since we know that that's 0 and that's 0, we end up with that at any time. The position is 1/2 times the acceleration times the time squared, which is 1/2 the ratio of the pushing force to the mass times the time squared. And so the thing we want is 1/2 13.54 newtons over 15.4 kilograms times 2.5 seconds squared. And that comes out to be 2.72 meters. So that's how far it travels in that time.